Hello. Good afternoon, sir.
Good afternoon.
Sir, how are you, sir?
Fine. You?
Sir, here is Dr. Bharat Gupta from NIT Patna.
Hello.
Uh, Voice is not come. Hello.
Hello. Can you hear us? Hello. I'm Radhakrishnan from Trivandrum. Can you hear me?
Yes, sir, we can hear you.
Oh.
Dr. Ravi.
Yes, sir.
MNIT Jaipur.
Yes, sir.
Sir, आ गए? Saula sir.
Saula sir is joining in 2-3 minutes.
Okay. Ravi sir, are you there?
Yeah, I'm here, sir.
Okay, okay. So, sir has already joined.
Uh, I think Saula sir is joining and he'll be introducing sir to the party.
Sure. Sure. Sir, still we are little bit earlier, not a problem. So we can wait for some time
Yes, sir.
for the participant to join, and in between, sir will join also.
Yes, sir.
Okay.
Yeah. Good afternoon, Mr. Radhakrishan. I am Vineet here.
Good afternoon, Professor Sally.
I'm sorry. Yeah,
Sorry.
I was just searching for your biodata. I could get some wiki. You didn't send me that. So we'll start in few minutes.
Yep.
Yeah. Ravi, should we start now? Bharat, good afternoon. Ravi, good afternoon.
Very good afternoon, sir.
Sir.
Very good afternoon, sir.
Yeah. Good afternoon to all team. This Mr. Rishi, Mr. Rajendran, and others who are still to join. Mr. Akshay.
Hello, Akshay has some difficulty to join. He just called me.
Okay. So he needs some help. We can start, and then in the background we can help him. That way. Yeah.
Yeah, let him try once again. He's
Okay, no problem.
discussing with our IT person.
Sure. So.
Yeah, we can start. We don't have any problem.
Okay. So, Bharat, I need your permission to read a small bio for Mr. Radhakrishan.
This is even
Good afternoon, participants and my colleagues. Today, we are very glad to welcome Mr. C.V. Radhakrishan ji. He is actually, if I say it will not be an overstatement, he is actually a proponent of LATEX in India, where under his leadership, the TeX User Group of India has contributed a lot and earned a good name. I have collected some of his bio. He didn't share his CV, so I'm reading some of his activities from his Wikipedia details. Mr. Radhakrishan ji was born in 1953. He had a short career in some ministries, Government of India, In Kerala, he was in the administrative department of Kerala University. And in 1993, he set up the River Valley Technologies on his own that way, which is very famous for, at least I know many things about River Valley Technologies, but at least one thing is very appreciable. They have documented in portable format about more than 200 scriptures of our old historical and mythical scriptures, which we have in our India, which government of India itself is not able to store. So it is, we should be thankful to him. All citizens should be thankful to him and to his team. Apart from tech, now he is active in River Valley Technologies. I will request him to give of River Valley Technologies. If I think the River Valley Technology is the same, which is publishing platform for IEEE UK, then I'm okay with that. So River Valley Technology is giving the platform for hosting manuscripts and processing them for IEEE, which is now called IET UK. He also had in copy for many activities. Mr. Radhakrishnanji, I apologize if I miss anything, but you can apply that for more things. Hand over to you, please. Thank you. Thank you for your effort and energy and for joining. Thank you very much.
Thank you, sir.
Thank you, Professor Salihu. Good afternoon to all the participants and also the organizers. My name is Radhakrishnan, CV. I'm talking from Trivandrum, the capital city of Kerala. We experience heavy rains here. Probably, I hope, it may not create problems with our internet connectivity. So I am a tech programmer, and also I am a free software and free content activist. In 1997, along with Professor Namboodiripad of Kerala University, I founded Indian TeX Users Group. Also in 2000, along with my colleagues, I founded the Free Software Foundation of India, which is the Indian chapter of Free Software Foundation in the US. In 1994, I set up my business, River Valley Technologies, which is a text processing company in the area of academic publishing. We process around 350 complex academic journals of Elsevier. So far, during the last 36 years, we have typeset around 5 million pages of research content. Having done this far, we have gone through most of the challenges that the research content can bring forth. As a free software activist and passionate follower of free software, I have contributed a few packages in LATEX, which is called libraries, and distributed under free license. Now coming to the main theme of what is TeX and what is LATEX. TeX is a typesetting system. It is developed by Donald Knuth, Professor of Computer Science in Stanford Univ. TeX is a very funny kind of text processing system. It employs markup language. Markup means instructions to the computer on how the string should be formatted or processed. So you have the content and the instructions are mixed together in your document. You submit that document to a compiler, and the compiler processes this content to generate the output. This is how TeX works. The program that compiles is called TeX, which is the compiler. And also, TeX has got a very good, powerful macro language, and you can write functions and definitions with which you can customize your processing job. So in order to make the job of usage of TeX easier, a scientist by name Leslie Lambert wrote a lot of macros with which you can do a lot of generic work. You can typeset book, you can typeset articles, and you can typeset a variety of things like reports, letter, curriculum vitae, and things like that. So if you look at the right side of this page, you will find a source. Under the source, this is how we enter the data. We have the instructions there. This is called markup. Head, itemize, item, and you see the env. You can see the output in the below. And you see, you simply put all these things there and also the data, and you submit and use later to compile the document, and you get this output. This is how TeX works. And it's very classic language, and it is 40 years old. We are going to see all these things now. So at this age, where we have graphical screen-driven software, be it word processor or typesetting systems like InDesign, Quarkus, why should we go to LATEX, which is 40 years old and is very classic, and it doesn't support any menu-driven graphical screens. So many of you might have created a thesis or a dissertation or a long document with a lot of chapters. And when you complete your work, first draft of your work with a lot of chapters, with a lot of objects neatly arranged, sequentially numbered, and you submit that to the concurrence or the validation or the approval of your mentor or your supervising teacher. And he suddenly comes up with a lot of change. He wants to move around certain things here and there. He wants to delete certain sections, certain equations, certain tables, certain figures. And again, he wants you to insert a few more things afresh. So it makes your document extremely difficult to work with. You lose your sequential ordering system, you lose your logical order, and also you lose all your cross-references, citations. It won't resolve properly. So in short, you end up with a document which is not at all sequentially correct or in a very, very difficult position to work on. It is at this time that you earnestly long to have some sort of system which should have made you free from all these miseries. Despite all these things, you write your content and the system should have taken care of. Yes, there is a system. That is called LATEX. The LATEX will take care of all these mundane naming, numbering, and all these things. And you just write your content in the most appropriate manner, and the LATEX will take care of all these things. So in order to use LATEX, there are several reasons for that. We can broadly categorize those reasons into three. There are historical reasons, there are semantic reasons, and also there are technical reasons. So let us see one by one. So historically, it was developed by Donald Knuth, as I told before, and that is primarily for the purpose of typesetting his own book called The Art of Computer Programming, multi-volume, monumental volumes. Still, it is considered to be the Bible of computer programming. So he wrote the first volume of the Art of Computer Programming. It's called The Fundamental Algorithms, and he gave it to his publisher to print and release the volume. When the Galley proofs were given to Knuth, he was extremely frustrated because of the poor typeset quality of the book, and also poor non-adherence of the math conventions of his equations. So he thought that he would write his own typesetting system to typeset the best book in mathematics. In fact, he accomplished that mission. In 10 years' time, he wrote TeX, he developed it, and he released it free to the world. So that's the story of how TeX evolved. TeX is a free software. Free software means as in free beer, that means you do not pay any money. And also as in free speech, that means you have the legal freedom to use it, modify it, copy it, and distribute it. And also it's a de facto standard for technical communication among the scientists. It is 36-year-old and still it is going strong. In fact, it is the most preferred typesetting medium among academics and scientists. And if you are using TEX, the longevity of your content is guaranteed. For example, the TeX book, which was written 40 years ago by Donald Knuth, which is the manual of the TeX, the source code of which is still available, and you can take that source code and compile it into the TeX book exactly in the same format as it was created 40 years ago. That's the kind of longevity feature that TeX provides to you. So as such, the backward compatibility is also guaranteed. Even if you create documents now, you can typeset that for years and years to come, which is unheard of in normal typesetting systems and other software we have now. Even across the versions, the documents become unusable. That's the kind of situation we have, and TeX guarantees against this difficulty. And you can also create high quality output with a relatively low input of effort. These are some of the historical reasons with which you should use TeX. Now you have semantic reasons also. You will see that in the document, you are mixing up content as well as the strings also, as the instructions also. That means the instructions will take care of the presentation of the content. So when you, just because you are separating the content and the format, you have the advantage of going on writing your system, content without taking care of the format of the system, format of your document. Suppose if you are using a WYSIWYG graphical screen-driven system, you'll be often drawn by the format of what you are writing there. Because in your WYSIWYG systems, the format and content are unified, unlike in TeX. So that will you will be carried away to the format of the content instead of concentrating on the content. So by separating content and format, you have additional advantage of modifying the document or the formatting of a document at a single place with which you can, the entire document will be consistently formatted in a different way if you want. And also logical division of content. You divide the book into parts and the parts into chapters and chapters into sections and sections into subsections, so on and so forth. And that gives you absolute control over your document. And there are several technical reasons also. Generally, TeX files or LATEX files are simple text files with content and instructions. It's not a binary form. So it's not vulnerable to any file corruption. And also, since the file size is also small, you can transport across networks very easily. And LATEX has got an excellent cross-referencing system also that seldom lets you down. So it's quite remarkable, and many people use LATEX for just because of this property, because of its cross-referencing system. So even if you change things later on, it will be recomputed and the new numbers will come in there without any effort. And objects are not numbered. For example, section or figure or table, and you simply say section and put the argument there. And even if you have hundreds of sections, you can move around whenever you want. And also, since there are no numbers there, and the numbers are computed at the runtime when you are creating the output, and it will be serially numbered, even if you move around the sections or the objects. TeX and LATEX is aware of how to typeset mathematics. The math conventions are properly taken care of, even without your extra effort or extra attention. And if you say A plus B, and the plus will have the operator spacing correctly. And if you simply say plus A, the plus will be treated as a sign, positive sign. So in there, the spacing is different. So all these nitty-gritty small things are, refined things are taken care of by TeX native. So you need not worry about anything. That's all. And TeX is also device and operating system independent. And most of the typesetting systems and word processors are dependent on the devices, which the kind of computer you use, and also the kind of operating system you use. Whereas TeX is cross-platform, it is device independent, and it is not bound to any printers. In normal case, most of the format is bound to the printer to which it is attached, or to which the device is attached. So in TeX, there's no such thing. Even you can create a document in Windows, you can typeset that in Linux, and you can print that in or view that in Mac OS X or any other operating system, maybe it mainframe also. And PDF can be directly written using TeX, LATEX. PDF with hyperlinks, bookmarks, with animations, and all the bells and whistles can be easily created. Also, you can create standards compliant PDF files. PDF fit for printing, PDF fit for web delivery, with some other purpose also. There are several types of PDFs, specifications are there by ISO, and you can create all these kind of PDFs with the help of TeX. Glossaries, indices, multiple indexes, table of contents, list of tables, list of figures, list of symbols, list of whatnot can be easily and automatically generated. The author need not worry about any of these things. And also you can seamlessly translate LaTeX document into other forms like HTML, XML, Markdown, etc. So these are all some of the reasons why you should use TeX, LaTeX. And in academic publishing also, TeX reduces the lag between submission and publication, provided you follow the author's guidelines in submitting their TeX document. Most of the authors have given class files and also have given bibliographic style files. So if you use any of those things, and if you submit with that, most of the publishers take very less time to publish your document. So it reduces the lag between submission and publication. And some of the preprint servers like Archive also directly accept text sources. And there are now online LaTeX services like Overleaf and Athria and kind of things. So you need not have a TeX installation locally. We also have LaTeX services just like Overleaf called TeXfolio, Neptune, XPC, and some of these things will be explained in the last session of today. And they gave notable services to continuously and used by biggest academic publishers in the world. And we are also ready to provide these services to Indian universities. And this will be discussed in later talks. Where to get TeX? And you can get TeX from the TeX Users Group. TEXLive is the annual distribution of TeX software. Online installation facility is also available at TeX or TEXLive. And for different operating systems, it's available for Mac OS X or Linux or Windows or any other operating system. You have that, and you can have online installations. A DVD is distributed by the TeX Users Group, and it's free for the members, but others can buy it for the cost of the media, maybe around $1. And the free package repository is at the CTANOR, and it's available. It's mirror around the world. There are 30 mirrors all over the world. And the Indian TeX Users Group has published a LaTeX primer, a tutorial, which is much acclaimed and used all over the world. It's available, books sign or ENPDF, primer.pdf. A PDF of this document is also uploaded to Professor Salihu, and probably you might get a copy from him. With this, I conclude my talk here, and I'm handing over to Rishi. Thank you for watching. I'm happy taking, if you have any questions, I can answer it here. Thank you.
Hello, just a moment. Let me take my presentation.
Participants, in between, I take this opportunity to apprise all other team members of Mr. Radhakrishnanji. Will be taken for a very good ride by other members, Mr. C.V. Rajagopal, Mr. Arvind Rajendran, Mr. T. Rishi, Mr. V. Apu, Mr. Rashmi Prabhu, Mr. S. Rahul Krishnan, and Mr. K. Akshay. And as we have jotted down in the detailed schedule, the journey would be quite interesting and covering all depths also. This is introduction to LATEX, which Mr. Krishnanji has just taken up. Then typesetting mathematics elegantly and easily, and writing manuscripts in LATEX, all using your ORC ID and other kind of aspects. Bibliography management, very crucial to LATEX and very crucial to every researcher. Publishing in print, internet. This might be complemented by Mr. C.S. Yogananda later also. And of course, one which is TechFolio, Neptune, XPC, which Mr. Radhakrishan just apprised us, are services to all, open to all universities. So we stand to benefit with them. Please be here and remain connected. Over to you, Mr. Rishi, please. Mr. Rishi, we also have copy of slides. You want us to slide them?
I can share from here.
Sure.
Sorry, can you see my screen?
Yeah, definitely. It's very much visible.
Okay.
Very much
okay.
visible. Thank you.
Thank you, sir. Okay, good afternoon all. I'm Rishi, and I'm from STM Software Engineering, the same company CV and his brothers have started in 1994. I'm working here for the last 24 years with them. Today, actually, I'm a bit nervous as well as glad for the same reason. Why I'm nervous is because I'm actually facing the faculties of for the first time in my entire professional life. And why I'm glad is that you're the audience we are actually waiting for to meet for the last 24 years, because you are the reason why we exist. And you create content, we are actually working on it. If you are not creating content, we are no more. These are the two reasons why I am nervous and glad. Over these years, in my professional life as a typesetter in this company, we have traveled across the globe, meeting the various publishers of science, scientific technology, and medical publishers. We have made a lot of demonstrations, talk to them, as well as the techies and many conferences. And this is the first time we are facing faculties. So thank you, Sahila sir and MNIT for giving us an opportunity. So let me start with. So the topic is actually production of research article for publishing in LATEX. Before we touch that point, we will just have some details about why it is necessary to use LATEX for article publishing. So, as you know, production of article for publishing is a task consists of data collection, typesetting, and finally publishing. Production of a research article for publishing requires considerable effort. For publishing, you have to follow certain guidelines and rules and regulations. And quality of the proof that you are getting and finally published article depends on the quality of the submission. The quality of the submission, what I mean is I'm not talking about the quality of the content. Actually, I'm not qualified to talk about that. The point I would like to highlight is that the quality of the submission means the files which you are submitting for publishing. For example, if you are creating a LaTeX article, it has a lot of custom macro files and a lot of figures, tables, a lot of input files, etc. You might be submitting as a zip file. If the zip file contains only the required files, that I would say it's a very, very good submission. Otherwise, if you include many duplicate files, lot of unnecessary files, the same file in different format, for example, the same figure in TIFF, JPEG, and PDF format, and the like, the publishers who get it for processing will be confused. Sometimes they will be using a low resolution file or a wrong version file, or you may be getting a lot of queries from them, or sometimes it may be there's a chance a wrong file get printed if you did notice in proofing stage. So that's what I mean by the quality of the submission. For researchers, you know, each article they publish are like their children. It is very much important for them. Each article is important to the researchers. And I would like to say, we know the feeling, how the researcher feels of his article. So we also take utmost care in typesetting your manuscript. So the three questions mainly are, when you create a manuscript for publishing after your research, the first question is, have you decided the publisher? Have you decided the journal? Now let's talk about the first 2 points. Have you decided the publisher and decided the journal? If you are a sensitive publisher, the publishers normally says the same thing, the word sensitive, sensitive author, sensitive author. If you publish lot, if you write research articles lot and publish more number of articles you publish in an year, you will be treated as a sensitive author. In that case, whatever you write, they will accept. You don't have to wait for their suggestions. You can straight away submit your article to that publisher or to that journal. Definitely it will be get printed. The content is good. But it is not the case with the new researcher or the person who is going to write for the first time. So they have to choose the publisher, they have to choose the journal. Now the question, very important question. Have you gone through the guide for authors? This is a very good question actually. Before you submit something, you have to go through the guide for authors. Now let's look into the details of this. Guide for authors, I will say use GFA, its abbreviation from now on. A well-drafted guide for author can be considered as a Bible. It contains everything. It helps authors to feel a better publishing experience. If you do follow that GFA, you will get a better publishing experience. It is very important stuff as far as the publisher is concerned as well. It is prepared with a lot of care and evolved from the experience in the past or the entire publishing life. They might have faced a lot of challenges, problems with the publishing, and with this experience and the lessons they learned from the typesetters, authors, and them, they have created this guide for authors. So follow this guide for author is very much important. Nothing more, nothing less. That means whatever is there in the GFA is important. There is nothing to avoid. If you take, if you see a document from the insurance company, there are a lot of things written. Nobody will read it, but GFA is not like it, like that. Whatever is there, that is important. The researcher who publishes article, who wants to publish an article in a journal, must read the GFA and follow that. Submission systems and typesetters workflows are tuned according to the guide for authors and other specifications. So publishing, earlier publishing was something like a typesetting and getting it printed on paper. Now it is not like that. You provide a digital copy to the publisher. They convert it into various markup languages and different kinds of PDFs, print PDFs, web optimized PDF, and the source will be converted to XML, MathML, and these are hosted in different platforms. So all these conversions are happening automatically or semi-automatically. And for these automation, these conversion, they actually use different tools. Most of them, some of them are actually based on artificial intelligence, some using regular expression search replace, some using other softwares. Following the guide for authors will help reduce the communication and queries you may get. It helps error-free proof production, and proofreading will not be a nightmare. So now let's touch the point of, or the main topic of subject of this talk. Elsevier, as you know, is one of the biggest publisher who publishes 500,000 articles per year in 2,500 journals. They recommend else article family packages for the LaTeX manuscript submission. They have developed 3 packages, class files. First one in this series is else article class, then CAS single column and CAS double column. CAS is complex article service. So in addition to this, they have provided a lot of BibTeX packages, almost 17 or 18, and that much journal-specific templates also have been generated. These else article class, CAS SC, CAS DC are generic class files for manuscript submission. The BibTeX packages are to create bibliography from the BibTeX databases according to the journal style. So the right-hand side, you can see a screenshot of their LaTeX instruction page. You can see the else article document class they are mentioning here. C10. These packages are actually available in C10 as well. And now let's see what are the highlights of else article packages. The first thing is manuscript can be created in 4 different dimensions in single and double column format. Using the class file option itself, you can control how the column specification and the width, etc. 3 modes you can use along with the document class, that is preprint, review, and final. Review mode, if you use the review mode, it will give to the 2-line spacing and that type of changes in the document. If you use the final mode is actually not for submission, but for your testing purpose only. Once you prepare the manuscript, if it's a heavy complex mathematical manuscript, there will be a lot of lengthy equations, and they have to be properly aligned, etc. Before you submitting it in review mode or preprint mode, if you use the final mode and you typeset it, you have to break the equations how you see that in the final mode, because you are the best person to judge break the equation semantically. So if you leave it to as the task of the typesetter, their operators, sometimes they are the graduates, science graduates, they will break the equation according to their convenience or some conventions and rules and specifications. You may not like it, or it will not be semantically correct. When they break it, what happens is there is a chance for that equation breaking is not automatic, it's a manual. So there are chances for errors. So that will increase your burden of proofreading. You have to correct it. You have to send it back to the typesetter via the publisher. You will get another voice to proof sometimes. This back and forth, the communication will go on and go on. Sometimes the same error may find in the published article as well. In order to avoid this, if you use the final mode and typeset your article and align the tables, align the equations, etc., you will get a good proof back. There are options for loading different fonts like Charis, TeX, and TeX fonts. Easy and professional way of author affiliation linking. There are if there are multiple authors and multiple affiliations, the linking of these author and affiliation normally does in other class file like in article or some other class file is using superscript numbers. You have to tag it as superscript $, superscript 1, superscript 2, or superscript A, asterisk like that. But using else article class or CAS class files, which Elsevier recommends, there are professional way or structured way of tagging these affiliations. And for the case of title, there are a lot of options for tagging titles. You can give the normal title, subtitle, alternate titles, and translated titles. Again, the author field, you can include prefix, suffix, role, email, URL, or ID, link, social media sites, etc. Because you may be wondering, I can use it, I can just type senior or junior or my role in front of the name or after the name. What happens? Because all these things to be captured in a structured manner when these manuscript is converted to XML format. If you use else article class or the CAS SCDC class, what happens is you have to structure these according to the tagging scheme. When the typesetter converts this to XML or any other markup language, their automatic tool can easily understand which is what, and they can tag it properly. Otherwise, an operator must intervene and they have to mark it, which is what. As I said before, there are chances for errors. The proofreading task will make it more difficult for you. So, unfortunately, if there is a deceased author, there's a tagging scheme for marking deceased author. Biographies. Normally, biographies are given as a separate document and mentions that. But there is option to include biographies and linking that with the author list. CJ, Chinese, Japanese, Korean authors can be differentiated. I mean, when tagging, you can mention this is Chinese author, this is a Japanese author, like that, so that the surnames and given names can be flipped according to the convention. Multiple abstracts like normal abstract, graphical abstract, stereochemical abstract, highlights, etc. can be tagged. Keywords like normal keywords, MSC, PACS, etc. can be tagged. There are 14 different BibTeX style files available. Then now what I'm going to talk is about the to-do list. In the to-do list, or already done but need to be released. Adding structured affiliation, like there is a chance for you can mark it as which is the organization, which is the department, which is the country, which is postcode, which is city, etc. And you don't need to leave it to the typesetter's task to identify these wrongly. And for LSAT packages, there are 24/7 online support, email support available. So now let's look into these features in more detail. So we have two class files. I say LSAT class is there already, and CAS SC and DC for double column and single column. FLEQ for aligning equations on the left-hand side, and long make title. Sometimes there will be more number of authors and affiliations, like collaborators, and the abstract may be lengthier. In that case, it is a difficult job to break these in the first page and to typeset in next page. So there's an option in the class file, long make title option. If you use, that will be automatically broken, and it will be nicely typeset in 2 or 3 pages. Then title, how many different types of titles we can use. You /title, mode equal title, it's a normal title. Mode equal alt, it's alternate title. Sub means it's a subtitle. Trans means translated. There's a chance option to give the subtitle for this translated title as well. So for coding authors, this is the coding scheme. Author 1,3. 1,3 is the affiliation, linking and the affiliations. Assume there are 3 affiliations. The first author is affiliated to 193. So 1,3 given. Author name, type, author unique ID, biography is given, biography ID, prefix, role, work ID, Facebook, Twitter, LinkedIn, Google Plus, etc. Now as per the new convention, credit is also will be given. So which are for the first author, the credit is for conceptualization of the study, methodology, software. We can tag it using this credit tag. And all these other options are available here in addition to this. Prefix, degree, role, collaboration, anonymous. If you want to make the author anonymous, you can use anon. So that author name will not be printed. Okay. This is how affiliation is given. Address 1, address 2, address 3. The 1 and 3 we have given to assign to the first author, as you see in the previous slide. Title. Now let's see some of the how the footnotes to the title, author, etc. is given. Mode equal title. You type the title here. Title not mark 1,2. That means title T note text, T note text 2. These marks are actually given here. That means 2 footnote assigned to the title. So author, how we use these author marks. You can see the author name, C.V. Rajagopal, coordinator, junior. Then corresponding, he is the corresponding author. There are 2 footnotes for this author, FN mark, email ID, the URL. FN text, FN1, FN2 is the label. Yeah, there's a mistake in this here. Actually, it should be FN1 and FN2 here. I wrongly checked up. I will correct. Abstract, the begin abstract, graphical abstract, highlights. There is one more pseudochemical abstract also can be given. Keywords, this is standard keyword. Each keyword is separated with the /sub command. You can also give comma, but it's better to use this sub command. So a table, this is a single column table, begin table and table, tabular star, table width, that is a table which fits on the single column mode. This is for span the table that spans over 2 columns. You have the options to give the width, calls, position, etc. Figure, this is single column figure and double column. The only difference is double column span for to the 2 columns. You have to use star. Normal options of the include graphics, scale, width, height, etc. there. And enunciations like theorem, lemma, etc. There are 2 different enunciation how it is printed. Theorem, lemma, proposition, etc. normally printed in italic. So if you want any enunciation which you want to print in italic, you have to define them with the new theorem command, new theorem, and how it is printed here. So if you want it to make, make it Roman, define that environment with the new definition command, new definition. So this will be printed as Roman here. Again, a mistake. It should be definition here. New proof of theorem. This will also be printed in Roman. Biography. You can use code biography like this, bio. And that's all.
Rishi, before you wind up, I think there are some questions that have been asked in the Q&A. If you click on Q&A, you can see them. There are some questions, so if you want, I can read them to you. So the first question is from somebody. So first question is from Ashima. So the question is overleaf and LATEX same? So
actually, overleaf and LATEX. Overleaf is actually an interface where you can use LATEX. LATEX is actually the software. Overleaf is actually built on LATEX.
So simply put, overleaf is like a web interface which you have created for the LATEX software. So LATEX is generally what you download from the LATEX site, and then you can, it's a compiler that you download, then install, and then on your local machine you can compile and you produces a PDF output. But overleaf, what they have done is they have given a web interface for what you're doing in your local machine, so that from anywhere you can actually compile and produce your documents. So just like overleaf, we also have a system which is called as TechFolio, so which also does the same thing that overleaf does. So it's like LaTeX compilation in the cloud. So now the next question that has been asked is, how can we organize our review work with LaTeX? So that's not go. Is it safe to work on overleaf? So overleaf is a hosted service in the cloud. So what happens is, if you are having some sort of private data that you would not want to upload onto some private servers which are owned by somebody else, then you need to think about whether you want to upload your data there and then do the compilation. So this is one reason why we are also into offering services like overleaf. So it's called as TechFolio. But the difference is that we want to give you a service which can be hosted locally. So these sort of data privacy related issues can be avoided. So I think that's the answer for it. Then the next one is, how can we organize our review work with LaTeX? So LaTeX is just a compiler. So what happens is, when you keep compiling, it produces a PDF output. But these sort of interfaces, like what we also have, we have something called as Neptune, which is specifically used for the author proofing, and it's used by the author community itself. So this sort of a tool can help you with your reviewing work, but as such, LaTeX can't do that because it's just a compiler. So how can, what was the next question?
What is approximate duration between article under production and online publication of articles?
I think Rishi, you want to take
Actually, it will take 2 or 3 months, I would say, in our experience. But now the publishers are thinking seriously to reduce it to 10 or 15 days time. So it actually, you also have the researchers who writes manuscript also have a role in it, how fast their manuscript should publish. So it mainly depends on the quality of the submission as well. If there are no more queries, there isn't any confusion at the typesetter side about the submissions or the files you are submitting, your article, you will get your proof very quickly back. So normally it will take, I think, 2-3 months time.
I think the last question is, please explain how equations are put using LaTeX. I think somebody from the organizing committee can answer this.
No, it's actually, our next slide is that. Next talk is about
equations.
putting equations. Rahul is going to talk about equations.
So next one is, if you could give a demo of the same, it would be needful. We already have that session lined up. So I think most of you who are attending this session, it would be better that you attend all of these in one go, because there are a lot of content which can't be fitted into a single session. So some of these things will overlap. So it's better that you look at all of our sessions together. So why tech is not as popular as Word templates in every journal and conferences? Any tool to convert tech in Word template and vice versa? So there are some tools which convert Word into LaTeX, and that sort of thing is possible, but it's not recommended as such. So when you're doing scientific work, so LaTeX is the de facto standard that's there. So mostly if you want to properly typeset scientific work, then the recommended thing is that you go with LaTeX. So why is it that people don't use this that much? I think the scientific community, almost 70 to 80% of the scientific community use LaTeX. So it's not really true that Word is the popular template around. So it's mostly LaTeX. And the advantages of LaTeX are multifold than what you would see with Word templates and so on. Which one is the best to, what is it that Rishi,
which one is the best to work TeXmaker or TEXLive? Sometimes one gives error, other while other do not. What could be the reason?
There's a question which says, which one is the best tool to work, TeXmaker or TEXLive? Sometimes one gives error, while other does not. I don't think it makes a difference between which compiler you will use. Maybe there are some sort of options that you have which relaxes certain conditions which allows you to compile.
Actually, TeXmaker is an interface with which you can typeset a document. Whereas TEXLive is a standard text distribution. So you can't equate with the TEXLive and TeXmaker. TeXmaker is just a graphical interface that helps to create and typeset a document in TeX.
So in terms of the question that you asked, those would be some error check stop mode or something that you be available in TeXmaker, which you can enable easily, and then it compiles it, but does not make any difference. So the next
How
question.
much time will it take to be expert using LaTeX for organized research work?
That depends upon your intelligent quotient. You can be an expert within say 3-4 months, or it might, for some persons it takes around years. That's not the case.
I think once you're in the scientific world of creating articles in the academic world, and you're creating articles and so on. So once you learn LaTeX, it's gonna last you for your lifetime. So by the time you keep publishing more and more articles, you will definitely become an expert in it. So the beauty with LaTeX is the more you work with it, the better you get at it. It's not like simple softwares where you click on certain buttons and then you get a result. But there are a lot of tools which have come out, like what you were somebody was talking about, TeXmaker. Then are tools like TeXfolio, then the tools which are available on the internet like Overleaf, then TeXstudio. These sort of tools make your work much more easier. But learning LaTeX is very important, and you should understand how LaTeX works. Only then you can actually typeset and produce very good documents.
If you want to publish in a Elsevier journal, we have to download else package and start modifying. Actually, you do not want to modify the packages. Packages are written according to standards of the to submit your manuscript to Elsevier journals. But there are templates available. You can make use of that template and you can modify it. You can replace the text in that template file, and you can start inserting your text, and you just need to compile. If there are any problems you face because of your the coding mistakes, or you have any doubt, you can definitely contact through their support system.
So basically, it's like you're taking an existing document which has all of the tech, in the sense else article class related syntax in it, and then you're modifying your text wherever you want it to be modified. So that's just a shortcut of doing things. But if you want to do it the right way, the best thing is to read the documentation, for the else article class, understand it properly, and then typeset your documents. Anything more, Rishi?
Oh, yeah, there are more questions.
Many journals don't take submission in TeX templates. It is very difficult for a TeX user to use Word templates. I wish it becomes more acceptable.
Yes, we also hope so.
We also hope that it happens in that manner. So I would say that in case if some journal is not accepting it, you choose a journal which accepts LaTeX and you submit it there.
Can LaTeX be used for writing social science qualitative research work, as it is more popular among science community, not social science research community?
So you can use it. See, typesetting mathematics is what you can say is it's like the holy grail, or it's the most difficult thing that you can do. So when you want to do something this complex, it can actually do everything. So LaTeX was built for actually producing beautiful books. So in social sciences, you don't have this level of complexity that you would find with mathematics and so on. And then it actually helps you. I think if you learn around 10 or 15 commands, then you can typeset beautiful documents. And LaTeX is a beautiful tool for social sciences. Say, for example, when it comes to legal work, legal documents, all those things, LaTeX is the best tool to use. The only thing is the difficulty in learning it, then installing LaTeX on your machines, and then getting used to using it is a slightly difficult part, which most of the newer tools like Overleaf or R tools, they all address it so that you can use the nice WYSIWYG interface and you can type in. Only thing you have to know the LaTeX syntaxes. So the next question is, can LaTeX be used for, that's the same question. I think.
Please complete the 3 questions. Yeah.
I think we have completed it. So I think we'll move on to the next session, I suppose. We have overshot it by 2 minutes, I think.
So thank you, sir. We have actually completed this session.
Thank you, Mr. Rishi. We can proceed with the next one.
So, okay. So next is actually Rahul.
One more request, like we have half a gap between 2 sessions. So any 5-10 minutes overshoot and other thing we can be absorbed anyway. So it is at your convenience. No problem. No problem. Thank you.
Yeah, thank you.
So I will stop sharing and let Rahul Krishnan start with his presentation. No, Rahul is doing that.
Sir, hello, this is Ravi from MNIT. There are actually many questions which are also put on the chat board. So,
okay.
You can take a look there.
Yeah.
Ravi, we need here.
Sir?
We can compile from chat and maybe we can recite them for that.
Okay, sir.
Sure.
Okay, sir.
So is my guide?
So can we take these questions now, or will you compile these questions and we will answer?
These can be taken.
Very much on you. Very much on you. No problem.
No, okay. We'll answer it then. If my guide does not have knowledge in LaTeX and I'm writing in thesis in it, if so, in which formats I can extract my LaTeX document to get it checked by my guide. So the LaTeX produces a PDF output. So that PDF output is what your guide can look at, and then they could they'll see most readers like the Adobe Reader provides you annotation function. And using annotation, your guide could actually make those annotation marks and say what is the corrections that needs to be done. And then you can bring those corrections back into your LaTeX document, and then you can move ahead with it. So what is the next one?
Please type in your question.
No, that is something that I typed. You can go down. There are no other questions on top. I think that's the only question.
Let us just
And that's
all. That's only one question.
Yeah.
So before Rahul Krishnan starts, Aravind will give an introduction. Let me take his presentation. We are actually using the same, sharing the same room and same computer.
Mute, just mute it. Just mute and stop. Need to present. It's not presented. Control Alt Shift H.
Hello, everybody. Hello, everybody. So I think Rishi concluded the first session, and I think I'll start off with it. So mostly you would be thinking, what is a big company like us actually taking these sessions and so on. So if you think about it, what Rishi was talking about, at one spectrum, all of you would be coming in, and at the other spectrum, when you want to actually publish your articles with a publisher, they just generally come to a typesetting company or vendors like us to get their work done. So at the end of the day, it's like you take a coin. There are two sides. On one end, there are the other community, and on the other end, we come in. But unless and until the other community understands what are the intricate things that goes into publishing, it becomes quite difficult for you to understand what really goes into publishing and how a document comes out and so on. So this presentation would address some of those things. It will move on to those things, and then Rahul would come and explain how you could actually produce elegant mathematics using LaTeX. So when we are going to be presenting, we are not going to be using the standard LaTeX installation that you would find in most of the systems, wherein we would be using our own system, which is more like Overleaf. It's called as TechFolio, and that system would be used for typesetting mathematics. The only difference is you take the same code, you run it in the local installations that you have in your own machines. It would work. There won't be any problems. So the presentation starts saying that what is really happening in the industry, because COVID has disrupted most of our research work, and people are not able to go to universities, get their work done. So publishing is at its low. And in this in this situation where publishing is at its low, we are wanting to come out and bring in more tools and so on to empower the publishing community. When we are talking about the publishing community, it's more about the author. You want to give specific tools to the author so that the author is able to produce beautiful documents, share this knowledge that each and every author has with the entire scientific community, with the world at large. And the information exchange happens quickly, and it's not restricted by certain conditions which are set by the publishing houses and so on. So the model of self-publishing is something that we want to promote. And when we are talking about self-publishing, it's not specifically the author specifically publishing their documents, but it's more like a cluster publishing, wherein universities or institutes which have their own journals, and their journals can be published in the same standards or in the same way as big journal houses publish them. So without any ado, I'll start off with my presentation. So this just talks about the entire company and so on, how we are structured. So Radhakrishnan and his brothers together set up the company quite close to 25 years ago. So if you look at it, you will be able to see the 5 entities that are there. So River Valley Technologies, Sayana Foundation, STM Document Engineering, STM Software Engineering, and then Trivik SRO. So these different entities are the ones which are churning out all these products and services, and also taking care of the journal typesetting work for the big publishing houses in the world. So we operate mostly out of our campus in Trivandrum, and whatever pictures that you see on the right are mostly pictures clicked from our campus. So we have a campus which is spread across 4 acres, and we have a lot of fauna and a lot of insects, all of them being there in the same campus itself. In a way, you could actually say they also do most of the LaTeX coding for us, is how you can put it. So this just gives you an idea of how we are. So we believe in an eco-friendly environment and working in that sort of a manner. So that always goes into everything that we do. And we do journal typesetting for for Elsevier and PeerJ. So PeerJ is an open access journal, so publishing house. So most of the journals that they have are on open access. So mostly all of you others will be knowing it. So the other services that we have are all those things that you see there: TechFolio, Ethel, Neptune, and Neon. So these will be discussed in the later presentations that come through. So I'll just move on to the next slide, wherein we are talking about what is traditional publishing, then open access publishing, and self-publishing. So the main difference between traditional publishing and open access publishing, it depends on who pays for the articles that you read. So in traditional publishing, what happens? It's mostly about subscriptions of mostly the print journals, and then print journals, each institute subscribes to them and you pay hefty charges for them, and that's how it goes. So it's the reader who pays in traditional publishing, whereas in open access publishing, mostly what happens is it's the author who pays. So the author pays to get their content published in various journals. The idea of open access publishing is much more revolutionary than the traditional publishing model, because the author wants their work to be read, and then mostly what happens is the privileged classes are mostly the people who are able to read these articles which get published in journals and so on. So this sort of a model does not work with most of the countries like India, wherein open access publishing would actually be much more beneficial. But the problem is getting authors or funding authors to make those publications, pay for those publications to get them printed is a difficult task. So that's where the model of cluster publishing or self-publishing that we are talking about comes into play. But why does that model never pick up? Is because there are a lot of complexities involved in it. So if you look at the various complexities involved in self-publishing, is the designing a process, then the lot of development costs involved in the setting up the tools, systems, running the infrastructure, then making sure that they meet industry standards, then keeping on maintaining the systems infrastructure. Then as time goes on, the standards keep evolving, and then you have newer standards, newer document formats which come out. All these things have to be addressed. So when this sort of a thing happens, smaller institutes or universities will not be able to take care of all these things and keep out or maintaining their systems so that they are able to do self-publishing. But this is where our tools will actually help institutes like yours, the universities and so on, to move towards cluster publishing or self-publishing. So it's more like multiple universities could join together, have your own journals typeset in the same standards as big houses typeset them. You can have all those tools that mostly the big publishing houses use, so that you can deliver the same content in the same level of quality as they would. So this is what we want to change by moving towards self-publishing. So if you talk about our experience with LaTeX, we have been with using LaTeX. So LaTeX is our bread and butter. We have been doing that for the last 25 years. So we brought into fore the Indian TeX User Group, which started in 1999. So Sebastian Rutz, a very beautiful or powerful tech programmer, is whom you could call him, inaugurated the TeX Users Group conference. And then we are also the founding members of the Free Software Foundation in India. So we started off with the Free Software Foundation, so which mostly a lot of people might not be knowing about it. So in addition to that, we have actually committed a lot of packages, class files, and so on, for which have been released for the others into Sept. And Rishi was also talking about a lot of the ELS article class and so on. Most of those things, a lot of support activities work has been done by us. So in 2002 and 2011, we organized the TeX Users Group conference here in India. So we are committed to making sure tech gets used across the world. So we are proponents of that. So for the last 15 years or so, we have been working with Elsevier. Then in addition to that, we've been working with PeerJ. Then there are a lot of other major publishing houses with whom we have worked in the past. In addition to that, we also work with Indian publishers. One of the publishers that we work with is DC Books, so which is a publisher here in Kerala. I think most of you might be knowing about DC Books because they publish a lot of literature in English also. And then we provide services for Elsevier. So Neptune is a tool like Overleaf, which has been provided as a service for Elsevier. And then if you talk about who helps us with the development and so on, we have Handatan, who is the PDF tech developer. So he works with us. So that is something that we are very proud of. The person who has produced the PDF tech package, the tech package that all of you would be using to produce your PDF documents. So this same person works with us. So that's something that we are very proud of. So the next slide just talks about what are the various stages involved in journal production. So you would all be knowing about it. So it starts with submission, then it moves into peer review. Then finally, once it is peer reviewed and then accepted by some of the publishing houses, it goes into typesetting, proofing, copy editing. Then there's artwork processing, which also is an important part of getting your documents published. And then once it moves into the next stage, you see web publishing. In web publishing, you have the EPUB, PDF, HTML, then images getting generated, metadata information. In the newer world, what has become more important is the metadata collection that goes into most of these articles. So metadata becomes a very key part of it, because when you want to have search engines search through your articles or the content in those articles, the metadata becomes very important. And these are the information which becomes output deliverables of most publishing houses when you produce the documents. And then still printing is an important output or deliverable of existing journal production workflows. So what happens is the PDFs that you generate have to be validated PDFs. So there are various specifications for those PDFs. So generally, when you use PDF LaTeX and then you produce the final PDF, it might not be a validated PDF. So on top of it, you have to do a lot of things so as to enable them for to be used at the various print houses and so on. So our tools take care of those things. And then the most important area is archiving. So archiving is still in its nascent stages. Mostly the work that you do are not at all getting archived with most publishing houses. So this is one key thing that we take care. So we have we use for us the archiving format is itself XML, and then based on the various BTDs that are there, we produce the archiving format. And LaTeX is also a very powerful archiving format when it comes to storing data as it is. So that's the beauty of LaTeX. So it started off like 30-40 years ago, and still the same format can be carried forward and then be used, because it's itself a markup, and you can use various tools to actually derive data out of it based on the markup format and so on. So the entire journal production tools that we have are split into TechFolio, Ether, Neptune, Neon. So the reason why I'm just giving you a brief about these tools is because you would be seeing these tools in the subsequent presentations and so on. And there is a specific presentation at the end of it which talks about online tools. But when you hear about all these things, it will be too late. So I just wanted to give you a brief overview about the tools that are there. So TechFolio is a tool like Overleaf. It is a complete journal production tool. And then there is Ether. It is also a journal production tool. The only difference is TechFolio is used for Latin typesetting, whereas either is used for the non-Latin typesetting. And then there is Neptune, which is used for author proofing. This is a question that somebody asked earlier, how do you use it for your review work? So this is a tool that can be used. And then there is Neon. So Neon plays a very important part in producing PDFs from XML. So mostly XML has become a de facto standard in terms of archiving data and keeping it safe. So from an XML, if you want to produce different formats and so on, it's very difficult to do it because PDF tech can only work with LaTeX. And XML, from an XML, if you want to produce it, the tool that you use or the tool that we use is Neon. So it's called as XPC. So it produces a PDF output from an XML. And all of these put together can be called as our services and tools, in which all of these tools are available in the cloud. So it's not like you have to have your own installations, and the learning curve involved in using all of these tools is quite low. And the other power of these tools is like they allow you to work from anywhere. So even if you're sitting at your own desk, you can actually produce beautiful documents sitting right at your desk and get all of your publishing work done from one desk, and you don't have to move from there at all. So these tools are powerful tools, and you could actually say that moving publishing from the new normal to where we stand and so. These are the other strategies that's there. So there are two strategies that are involved. So generally you submit a LaTeX file, and from the LaTeX file you produce a PDF and all of the other deliverables. So this is called as LaTeX first. Whereas in the other methodology, you don't start with the LaTeX file, you start with an XML. From the XML, you produce a LaTeX, and from the LaTeX, what we do is we produce the various formats. So in terms of how you look at it, from XML, you start with XML, you produce HTML, PDF, EPUB, strip-in, any other format that you want, you have to start from an XML. So doing this is not very easy. And in a way, we could actually say we are one of the few companies in the world which have successfully done the conversion or a generation of various outputs from an XML input. So this is something that we are very proud of. So this just gives you a brief idea about it. You would be receiving these presentations, and you can go through them in detail. And then if you have any doubts, you can come back to us. But in terms of understanding these workflows and so on, this would just give you a brief idea. So this is how a production house like us works. So you, from a publisher, it starts, then it goes into a tracking system. From a tracking system, immediately you take the source files, and then you decide what you want to do with the source files, whether you start with XML or you start with LaTeX or you start with the Word file. In our case, what we do is, even if it's a Word file, we convert the Word file into a TeX document. And from the TeX document, what we do is we produce the various results that we want, a PDF, the XML, the strip-ins, the images, and so on. So the various stages involved in the auto structuring, then comes the pagination or the typesetting, real typesetting, then author proofing. That's where the Neptune tool comes. So in the entire end-to-end chain, we have various tools that we use, and all of those tools are there in the cloud and available for maybe once people want to move into self-publishing, institutes like yours, if you want to move into self-publishing, these can be used. I think I'll just give you a brief idea about TeXfolio. So this is the complete journal production tool, which is there in the cloud. It can be used on any browser of your choice, say Chrome or Firefox and so on. And you can actually typeset and produce industry standard articles by sitting at your own seat. So this is something that the other guys would be presenting and showing it to you. So in terms of understanding, TeXfolio is more like Overleaf, but is a much more powerful tool than how you would see Overleaf. So Overleaf cannot produce an XML output, whereas TeXfolio can do that. And one of the key things which maybe institutes like yours or universities could think about is, from a LaTeX, if you have a LaTeX document, if you want to go in for web publishing, so if you just want a HTML output to be available and you want to publish your work across various web servers or on the internet, then TeXfolio can produce HTML output without much difficulty at all, and that can be used for your web publishing work. So this is something that is very powerful. This is something that the tool can do and is a very powerful feature. So the input formats that TechFolio can support is the Elsevier journal article DTD, and then the NLM or Chats XML DTD. So these are the two. And if you think about it, if you want to start your own publishing work, and then I would suggest that you choose any one of these DTDs. Or if you want to use the much more open, both are open. And if you want to use the open access one, then the JATS XML DTD would be quite sufficient for you. So this is about TechFolio, and the other tool is Neptune, which is used for author proofing. So this will again be addressed later on. I think with this, I will stop and I'll hand over to Rahul, who will actually explain how you can actually typeset or typeset beautiful mathematics using the TechFolio tool. Okay, so over to you, Rahul.
Hello.
So Rahul, I'll stop sharing. You can start sharing. Okay.
Yeah. Am I audible?
Yeah, you are audible. You can go ahead, Rahul. So Rahul, you can start, Rahul.
Yep. Sahula sir, can you please let me present
just a minute.
my screen?
I'm making you presenter.
Yeah. Okay. Thank you.
So Rahul, in the meantime, when you set things up, there are a few questions here. So maybe just I'll answer them. Okay. I think those questions have been answered. So I think Abu from our team has answered all these questions. Okay.
All right.
Rahul, go ahead.
Can you see me?
Yeah, we can see you, Rahul. You can start.
Yeah. Yeah. Okay.
Yes, Mr. Rahul, you can now present.
Yeah. I got it. Can you see my screen?
Yes,
Hello?
it's visible.
Yeah. Thank you. So, thank you for giving us this wonderful opportunity to present something like this in these big participants. So let me introduce myself. I am Rahul Krishnan and I am working for SCM Software Engineering Private Limited. Today I'm going to show you how we can typeset mathematics elegantly and easily using LATEX. So as an introduction, let me ask a question. What is an equation? Yeah, we all know what is an equation. Simply, an equality is an equation. And this equation contains different components like variables, operators, subscript, superscript, fractions, roots, symbols, etc. And all of these can be easily and precisely typeset using LaTeX. That's why the LaTeX is the most prominent software in this industry. So in this presentation, I'm basically discussing about the main features and usage of AMS Math package, which is a library in LaTeX, which is an exhaustive package to typeset mathematical expressions. So equations can be divided into two. inline and displayed equations. I'm saying in connection with the typesetting area. So in that we have divided these equations into two. So inline equations are those mentioned inside text area, and the displayed equations were mentioned outside text area, and that was begin in new line. So now let's go for a typesetting. Here, how to typeset an inline equation. To typeset inline equations, you should put your expression inside two dollar sign. As you can see here, to typeset this sentence, adding two variables x plus y to get z. The code is here, variable dollar x plus y, again dollar closed. To get, again, this is a variable, so that was put it in the dollar starts and ends. So as Xavier and Rishi said, here there is the operator. You can see the operator in the code. There is no space around the operator plus, but in the output there is a precise and accurate spaces around the operator plus. So when the dollar starts, the font and the spacing also changed automatically. And also I have put this variable in dollar. So in every equations, these variables should be consistent around the whole article when you typeset. So to make that consistency, you should put those variables in dollar. That means in the inline equation. So now let's go for the displayed equations. So to typeset this displayed equations, that is again classified into two, numbered and unnumbered equations. So as you can see here, this is a quadratic equation. So here this is the output, and it has an equation number 1, and this can be typeset using this code, begin equation and end equation. This is an equation environment, and you should put those expressions inside this environment. Going some more deep, you can see x is equal to, then here comes a fraction. It have denominator and numerator. So here the command starts /frac, and the first argument is the numerator that comes in this group, and the other one is the denominator which comes in this group. And this grouping is important for any sort of expressions. Then going inside the fraction, there is minus b, then plus or minus. That symbol can be typeset using this command /pm. Then comes the square root, that sqrt. Then again that group makes this root a bit longer, that is b square minus 4ac. So to get the raised to b raised to 2, you should give b the character symbol, that is shift 6 in the keyboard, and giving the 2 will typeset the b square. So you might have think this is very difficult. This can be done in the Vysavic softwares, but this is not like the Vysavic softwares. You all are known about all the types of equations. You are working with those equations, though, so you know the strings you have used for that equations. So what I'm saying is, this is a fraction, so the command is /frac, and this is a plus or minus, that comes in /pm, and the square root, that comes as sqrt. And these commands are very easy to remember while typesetting your article using LATEX. Okay, let's go to the next one, unnumbered equations. That can be easily done. Just adding a star symbol to equation environments to get unnumbered equations. As you can see here, just put the star symbol at the end of the equation environment. You can see here, which will remove the equation number. So let's go for the other equation environments. So we are dealing with different kinds of equations, just like integration, differentiation, algebraic equations, tensor equations, then matrices and determinants, all kinds of equations we are dealing with. So, and in connection with the equations, they depends on the context, and that context makes these equations different, and that should be aligned in different ways as the context depends. So here there is a alignment that if you need to get this type of alignment, just like multi-line equations, and it have a equation number, that can be done using this environment multi-line, that is begin multi-line, then the first line, then using this double slash, that is carriage return, which will break the equation, and the second line. So get this multi-line equation which have a single equation number, you can use this environment multi-line, multiline, and you can also make this equation unnumbered by putting a star at the end of this environment, as we said in equation, unnumbered equation. Okay, next one is gather. As the word says, let's gather the equations. So here this environment is used to put some group of equations which have an internal relations, and that should be typesetted in a group of. So here you can see this, there is no alignment, just giving a center alignment for all the equations, and those have the equation numbers. So going forward, next one is align environment. Here comes the alignment. To align these equations, the character we should use for the alignment is ampersand symbol, as you can see here. So to align these equations, you should put the equation expressions in begin align, end align, and here the character which we like to make aligned is equal sign. So we have put ampersand before the equal sign, which gives this output. Okay, next one, align at. So here this is also an alignment environment, but like a tables, we can mention the columns. As you can see here, this environment begin align and end align, and it have an argument 2, means 2 column. As you can see here, this one is first one, this one is second one. So that can be done, as we said in align environment, you should give the ampersand here and here, where we decides to be aligned the equation. Okay. Next one is FL align. This is an equation environment which stretches the space between the equation columns to the maximum possible width and fill the line. As you can see here, if you need some equation in this manner, you should give this equation in between the environment begin FL align and end FL align. And here the star is applied, so there is no equation number. Hope you all understood these environments. The next one is split. So sometimes some equations have a single equation number, and it should give some alignment. So that can be done using this equation environment split, and this can be used inside equation gather and align environments. As you can see here, This is a begin equation and end equation, which is a single line equation. But we need a breaking alignment. We can use begin split, end split. Just keep remember one thing I am going to say is label. I am label this equation using the string EQ colon X for cross references. I am going to take that section soon. So just keep in mind this is a label which labeling these equations for cross references, and that can be done using this string EQ colon X. You can give any character except commas. So going forward, the next section is about the features of equation numbering. We have seen the equations, numbered equations, unnumbered equations, and different alignment environment. And now comes the features of equation numbering. So we have equation which have a custom number. Previously we have saw 1, 2, 3, the serial numbers, and here I have put a command beta dash, that is my equation number. That can be done using this command slash tag. As you can see here, slash tag, and inside there is a mathematical expression beta dash, so it has been put inside the dollar, that this gives the output here, beta dash. If sometimes there may be multiple line of equations, that can be also done here. So sometimes this custom equation number may vary the vertical positions. To correct that vertical position, you can use the raise tag command. That will adjust the vertical spaces to adjust the custom equation number. That's all about the custom equation number. Next one is hierarchy. So when you're writing an article, there may have numerous sections and numerous equations that might confuse sometimes. So author wants to make that equations in a section wise or a chapter wise. That can be done using the number within command. Number within command, the counter means the section or chapter or subsection and so on. So according to the counter here, the equation will be renumbered. As you can see here, I have put this and section wise equation. This is in section 1, so the equation number becomes 1.11. So hierarchy can easily be done here, and also the number will be automatically renumbered all over the article. So next one, the cross references. So as I said a couple of seconds before, there is a label we have used for cross references. So that label can be cross reference here in this equation using this command eqref. This eqref will give the output in parentheses. So this is one of the feature in AMS math package. It will give the parenthesis equation number in the cross references. So you can use a slash ref also for cross references. For equations, you can use this command slash eqref and the label. So for example, this is the text from equation 10. We can say that A is equal to I, and this equation number comes from the equation 10, and the syntax is from equation slash eqref eq colon x. This is a string I have used in that equations. And here there's another expression which is put it in dollar because of that is a mathematical expression. And when I put the cursor in this cross references, I can click on it and go to that equation. That can be done, that the hyperlink can be done using the package hyperref. That is /use package. Hyperref package will enable the hyperlink. So when I click this number, I have been navigated to the equation 10. And here you can see the label EQ:X. Go back to the slide. Okay, and that's all about the cross references. Now the subordinate numbering, that's the sub-equations. So many of the equations need this because the context depends that equation groups belong to that particular number. So that can be done using this environment begin sub-equations and end sub-equations, which will give this output as 12a, 12b, etc. Okay. Next one, the miscellaneous features. We all had the various environments which we can typeset mathematics. Inline, let me some recap what I said last couple of minutes. For typeset inline equations, you should give the expression inside $2. And to get the displayed equations, you can use various environments, equation, align, alignnet, gather environments. And you can use the cross references using label ref mechanism. And you can use the custom equation number using tag command. And you can get the hierarchy using number within equation. So now comes the miscellaneous features, which I like to talk about, and there are many of them. I have taken some of the important one. Here the matrices, we all are dealing with some equations having matrices and determinants. So to get the slide itself saying that to get this output and this is matrices, you can use begin P matrix, end P matrix. To get the boxed matrix, you can use begin B matrix, end B matrix, and each cell is differentiated using the ampersand symbol. Once the line ends, you should give the carriage return to break the line. So 0 ampersand 1 gives the space here, and the 1 ampersand 0 here the spaces. So each column should be separated using this ampersand. Next one is B braces. The delimiter become braces. Then you can use the capital B matrix and end capital B matrix. Then for the determinant, you can use V matrix, end V matrix. Then if you need the double pipes, we can use V capital V matrix and end capital V matrix. Now another feature is boxed formulae. Yes, this is just putting that equation in a box. You can use this command /boxed. /boxed inside the braces. We can put the expression and will gives the output like this. Next one, the delimiters and the various sizes. So when typesetting an equation, the bracket sizes, the grouping in the semantic manner, the grouping is very important. So that grouping can be easily done using these various commands, and you can give these commands according to the equation insist. So here left right will give these brackets a bit sizer. Then that the size of the delimiters become increased while changing these commands. These are the examples and these are the commands. Going forward, next is the commutative diagrams. This is one of the best typesetting area in mathematics, the commutative diagrams that can be done using these commands, and you can use the AMS CD and XYPIC libraries for typesetting this kind of equations. They are available in the CTAN, and you can download it and read the documentation and use that commands to typeset these commutative diagrams. Then begin equation, star makes the equation unnumbered, and the begin CD that comes from the AMS CD package. The begin CD and end CD, then comes the expressions. Okay. Next, the limits. The limits when typesetting the integration, summations, the limits are very important. So when it is going to inside the displayed equations, that is here, the default output of the displayed equations, the sum I is equal to 1 to n means it always be in up, under and over limits. So sometimes the context depends, needs to be, that should be typesetted in online, that can be done using this command /no limits. And the converse is on the inline equations. The default output is online, and to get that use slash to get this kind of output limits. Okay. Now this skip link can give you exhaustive documentations to how to typeset mathematics. I am just giving a brief of that. Then this CTAN AMS package link and the symbols to typeset mathematics. You should know what are the commands are. That commands were listed here in this comprehensive LaTeX symbol list. So this is the presentation, and now let me show you the live demo of this equation typesetting in our typesetting framework TeXfolio. So let me take that our interface. So this is our typesetting framework TeXfolio. So I am going to typeset some equations in this interface. So let me log in this interface. By the time it gets loaded, let me explain what can be the inputs and out of this interface. So TeXfolio is a web-based framework which can typeset documents in LaTeX. So the inputs can be either LaTeX or XML, and the output will be PDF, XML, HTML, and EPUBs. So here I am taking some equations and giving you a live demo to typeset the equation, and from this document I am going to create XML and and HTML from the XML. So let us wait for a couple of seconds to load the text folio. In this text folio, we can create the entire production of an article from the submission to the dataset creation, the archival of the article. And the interface can create the strip-in images SVG in SVG and GIF format, and also we have the crossref, or that means the DOI verification, and the big file creations can be done in this text folio. Sorry about that. It's still loading. Sorry about that. I think that was a bit slower today, I think.
So I think Rahul, your net connection is not able to support audio as well as loading the page. If you want, we can share it from our end and help you with things.
Yeah.
Okay.
Maybe that is good for now.
Okay.
So let me stop sharing, and you can start sharing there.
Can the sharing option be enabled for CVR and Rishi?
Wait for a moment.
ഇതിന്റെ sharing option.
CVR. It is only for CVR, right?
Yes.
No, CVR and Rishi CVR.
CVR and Rishi CVR. All right. All right. Yes, that's granted.
Yep, that's the tech for you.
Rahul, are we audible to you?
Yeah.
So Rahul, once it logs in, just let me know where the files are, then I'll take it from there.
Yeah, just go to support and get into my directory.
Yeah, just for that.
So the people who are there viewing this demo can actually see this is the interface of TechFolio. On the left, you see the file manager. On the central half, you have the editor, and on the right, you see the output window. So right now, I'm
Yes, TechFolio. Go to TechFolio directory.
So I'm just going into Rahul's directory to pick the files. So because I have admin privileges, I can do it. So under TechFolio, okay, Rahul.
Then tug tug.
Tug, yeah.
Then JSTM docs.
Yeah, okay.
Then JSTM docs04.tech. That's the tech file. Bottom. Yeah. No. Above the JSTM docs04. Yeah.
This one, right?
Yeah.
So I'm just loading the file into the editor. So the entire tech file has been loaded. So this is the tech file.
So could you please increase the font size?
Yes.
Font size. Settings. 18.
Yeah, it's better now. Just close the file manager also.
Rahul, just tell me what I have to do. I'll keep doing it.
Yes, just change the XML option in the class file. Just change to tech. Then
Compile, right?
yes, you're correct. This is the interface and this editor. We have load the text file, and on pressing this PDF button will generate the PDF. Oh, just put the error stop mode. Just disable the error stop mode and compile it again. Yeah.
Oh, maybe because we are in the support mode. Let's copy and Rahul, just a moment.
Okay.
Yeah. Rahul, is this the file which you want to take?
Yes. This is the file.
I think for the time being, you can just explain the features, and meanwhile you can debug it.
Yeah, but
I think we can have this demo later in the last session.
Okay.
Currently, you can just keep on explaining the features and everything.
So yes, okay. So
You may keep. You can continue.
Yes, okay. I just want to try some equations in LaTeX. That's all I need to know. Do that. So that's all from my side. The equations.
Listings on the.
Yes.
Yes, but yes, that's the issue. I think accidentally put some numbers. I think.
Save ആയിട്ടില്ല.
So you should load from that directory.
One second. Let me log out and sign out and sign in again.
Arvind, just remove those packages. Star.pkg. Star.pkg.
1 second.
Just remove that and compile it again. Just go in. Compile again. Compile again. That's yeah, that's it.
I think most users would have now understood how to debug in TeX also.
Yes, that's it. So as you have saw the text file, when we compile the text file in TextFolio, the error will be shown here in the black screen, the bottom of the main editor. From there, we can debug the error and produce the PDF once again. So Arvind, can you please remove the equation number from the first equation by putting a star after the equation environment? Yes, there it is. Just put a star and the indent. Yes, then just compare.
This is the equation, right?
Yes, that's the equation. Yes, the equation number is removed. So just, sir, could you please go to next page of the PDF? Yeah, there we have some equations, and could you please change the equation or add some custom equation number to the equation 3? I think, sorry, 1. Yeah, equation 1. The current number is 1. As you can see, the number is automatically renumbered across the article.
This one down.
Yes. Slash tag brace open something dollar alpha dash. Yes.
Okay.
Yes, correct.
So each time when you hit on the PDF button, the compilation happens, like how you do it in your locally installed TeX installation.
So just press the plus button on the left side of the viewer. Left side of the PDF viewer. Yes. Yes, the alpha dash is here. So now let's create the XML of this document. This is our built-in class file, and we can have these options to create both XML and PDF. And here we have added the XML option, and just clicking this XML button will create the XML.
So generally XML compilation is very intensive and producing it is quite difficult.
Once again, please continue.
Cancel.
You're asking to change.
Oh, something is happened. So just go through the right line. 164.
45.
Yep.
Yeah, when I use the keyboard shortcut, I think there's
Yes.
the same key combination for the WebEx interface as well.
One 645. As you can see, the whole XML is generated from this text file. This is fenced something. So just go to the tech 259 line number.
Yeah, actually in the interface you can see the mathmal tag, the well formatted mathmal tag, the Unicodes of these symbols, and in order to debug it easily, the particular line number of the text source also included in this XML. You can see here line 259. Normally Control L will take us to the particular line number, but unfortunately it clashes with the WebEx interface as well. So we have to scroll down. Yeah, this is here it happens.
250.
No, this is the case, Rahul. I think the custom equation number that we have provided.
Yes.
That's the problem.
Oh, okay.
So instead of dash, we have to give something else.
Is just
Prime or
just
something?
put, or just put alpha alone. We can just need to show them what can be done in text volume.
Yeah, yeah. I think it has been validated.
Yes, that's correct. Yesterday I have put an equation beta dash in the equation above this one. Could you please go to, yes,
Beta
there
is
it is, there it is. So there is no error in that equation, but there is an error in this equation. That's okay. But we can typeset that here, and as well as we can generate XML from this text. So
Can you make HTML?
yes, create a HTML using this button. We can create the HTML. Yes, that's it. That's the HTML output.
Actually, the math is actually rendered using MathJax.
Yes, this is a mathmal.
Yeah, mathmal is rendered as MathJax.
As this, the custom equation number also there in this output. Beta dash and alpha.
Yeah, 2A, 2B. Table.
This is one of the example of XY matrices that which doesn't have any XML, so that here we have put it as images.
Yeah.
So that's it for the equation, how we typeset the equation and how we create XML from that.
So the thing is that actually, even though it doesn't have any mathmal or XML tag for these commutative diagrams or these type of structures, while creating the PDF, we never use images. These images are only used for XML alone. For PDF, the same source code which other uses in the text file will be used, and other will get the same quality output in the PDF. That's how we deal with it. Oh, sorry. Okay.
So that's it. That's all about the equations.
So Rishi is now again compiling the text file to just produce a PDF and show it to you. option.
Yes, that's it.
So this is the entire PDF of the document.
Yeah. Is it finished, Rahul? Oh.
Yes, yes, that's it. That's it, sir. That's all.
Yeah, now we can go for questions. Are there any questions asked? So I can stop sharing your screen, right?
Yes.
Let's go. Okay.
So let me see the questions. What?
I think there are no questions.
How to design mathematical formulas using.
I think Apu has answered most of the questions.
Yeah, yeah, yes, yes, yes. So during the presentation, that is a full screen, but I couldn't see the questions in between the talk. Yes. I think all of them, I think they have.
Yeah, no more questions.
I think
Yeah, I think this session is over, Sagala sir. So can we continue with the next one, or is there any break?
I think we can take a break now
Okay,
and we'll join back after 20 minutes.
20 minutes, right?
okay.
4:40. Yeah.
Okay.
Okay, thank you.
Thank you.
Thank you.